Hey guys, so you have learned how to do electron configuration, you've learned how to do the noble gas configuration, which is the shortcut. So the next thing we're going to learn about is orbital diagrams, okay? So for orbital diagrams, first of all, let's move on from this, sorry. Okay, orbital diagram. So you're going to want to copy this down. An orbital diagram is basically a visual that shows you where every single electron is located in the configuration. Okay, let me repeat that. An orbital diagram is a visual that shows you where every single electron is located in the configuration. All right? So we're going to represent it with boxes and arrows. Okay, and this basically just says what I just told y'all, that it's a drawing that represents the configuration. It's very detailed, shows you every electron. So boxes and arrows, well remember there's S, P, D, and F orbitals. So you're going to need to copy these different orbitals and how many boxes we represent them by. So if you need to pause this and copy that, go right ahead. Now, to do an orbital diagram, we are going to start with an electron configuration, okay? So we have to start with the electron configuration before we know what to represent the orbital diagram with. So I'm going to do one that's kind of short and sweet. I will do, let's do aluminum right here, number 13. And aluminum, the atomic numbers. So the electron configuration is going to be 1s2, 2s2, 2p6, 3s2, 3p1. Okay? So then, if I were to ask you to do electron configuration and orbital diagram, then after you have written this, you're going to represent that with the boxes and the arrows. Okay, so the orbital diagram is going to go underneath this. Now, as you had just written down, if you have an s orbital, so you're not looking at the coefficient of a 1, you're looking at just the letter and the exponent, okay, not the coefficients. So if you have an s orbital, how many boxes do you represent that with? You already wrote it down, it was one box. So that's an s orbital. This is also an s orbital. It gets one box. And then I get to a p orbital. Okay? So I can make it 3 boxes across, but it's going to be kind of hard for it to line up. So one thing you can do is just draw a vertical box like this, and that way everything's kind of tucked nice and neat underneath 2p6. And then we move on, another s orbital. That's one box, and then another p orbital. Okay, that's 3 boxes. Now, we have boxes and arrows, so I need to put arrows inside of these boxes. So in my first orbital, I look at my exponent, and I have a 2. That means I'm going to have 2 arrows. Well, if I start with an up arrow, and I have 2 electrons trying to occupy the same orbital, I want you to think about this. The electrons, they're spinning, okay? They're spinning on their axis, and they're rotating around the nucleus of the atom in a certain shape. So if they're doing that and you have one electron that's spinning and it's following the same path, the other electron isn't going to take the exact same path, okay? So the other electron is probably going to be spinning in the opposite direction, maybe above it or something, because this is a sphere, and so it's going to take up a certain amount of space. So instead of putting both arrows going the same direction in the same box, we are going to put an arrow going, our second arrow going in the opposite direction. Okay, so one's pointing up and then the other's pointing down. Okay, so that's 1s2. The 2s2, okay, we've got our one box for an s orbital, and then we have 2 electrons. Then we get to a p orbital, and the way we fill this up, there's actually 3 boxes 6 arrows, so it's really going to be 2 arrows per box. which is going to be 1 up, 1 down. But I want to show you what order we would draw these electrons in if we had less than 6. Okay, so we would do 1, 2, 3. So I want you to notice the first 3 electrons are going to be in separate boxes, separate suborbitals. Then when we go back and we fill up 4, 5, and 6, then they're going to point in the opposite direction. Okay, so number 4, number 5, and number 6. Okay, so it's kind of like if you're getting on a bus, you don't want to sit in the same seat as somebody, especially not now with coronavirus. You want to take up your own seat. So 1 person per seat until all the seats are occupied. Then you go back and you can sit with somebody when there's no other choice. Same thing with electrons. All right, this one has 2 electrons, and then this orbital only has 1 electron. So where does that 1 and only electron go? It's actually going to go in the top orbital. And having an empty orbital or an unpaired electron is going to say something about the stability of the atom and how reactive it is. Okay? So this is a orbital diagram. So let's do another example. If you need to pause this and copy it, you can do that. Let's move on and try to do another one. Let's do vanadium right here, number 23. So vanadium, number 23, its configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then 3d3. Okay, so we have to start with the electron configuration. Then we're going to do our visual with the boxes and the arrows. Okay, so I have an s orbital. That's going to be 1 box for that s orbital, 3 for a p, 1 for this s. I probably should have had y'all try this before I continued, but we're good. Hopefully I'll remember to do that in class and just pause it. This is an s. Okay, so a d orbital. How many boxes would a d orbital be? Well, it's going to be 5 boxes. And guess what? Don't forget, when you do these examples, they're going to go in your notes and not on your periodic table. So, hopefully, you knew not to write this on the periodic table, but if you did, try to erase it and put this in your notes. Now we're going to go back and we're going to add our arrows. So I want you to notice in each of these, you're going to notice a pattern. I'll just say that. So here we have an exponent of a 2. That means we have 2 arrows in that box. I need to make this a lot smaller. And then the next one's going to be 2 arrows. So 1 up, 1 down. Then we have 6 arrows in these 3 boxes. So they're all paired up. This one is 3s2, so that's paired in that box. 6 more arrows. Remember, you're going to fill it as 1, 2, 3, 4, 5, 6. Okay? And then we go to 4s2, so that's 2 arrows. And now we get to the very last one. I want you to notice something. For all of your examples that you're going to do, there are exceptions, but we're not going to worry about those exceptions. So for all of these examples, I want you to notice that every single orbital, those are the boxes, is completely filled up with 2 arrows until you get to the very last part of your configuration. That's always going to happen, okay? Because I'm not going to teach you the couple of examples where that's an exception. So when we get to the last one, we just really need to pay attention to that exponent. So that's 3d3. That means I have 5 boxes, but I'm only going to have 3 arrows. So it's going to look like this. 1, 2, 3. Starting from the top to the bottom. And notice that I have 2 boxes that are empty. Okay? I can't take those 2 boxes off because then this would appear to be a p orbital. P orbitals have 3 boxes. D orbitals have 5. So I still have to draw all 5 boxes. However, we're going to have 3 that are not paired, and then we're going to have 2 empty suborbitals. Okay, so if y'all have any questions, go ahead and ask that in class.